November 8, 1942, The Impossible Challenge. 12:01 a.m. Kaiser Permanente Metals Corporation Shipyard No. 2, Richmond, California. Under floodlights that turned midnight into artificial day, the first steel plate touched the keel blocks. Workers began the clock that would document what many considered impossible: building a complete 10,500-ton Liberty ship, 441 feet long, 56 feet wide, containing 250,000 individual parts, weighing 14 million pounds, in less time than most shipyards spent just assembling the hull. Henry J. Kaiser stood watching from the yard supervisor's office. At 60 years old, the construction magnate who had built the Hoover Dam, Bonneville Dam, and Grand Coulee Dam was about to demonstrate that ships could be mass-produced using principles he'd learned building highways and dams, principles that traditional shipbuilders insisted wouldn't work for ocean-going vessels. Kaiser had no shipbuilding experience before 1940, none. His background was roads, bridges, and massive concrete structures. When he entered the shipbuilding industry, maritime experts dismissed him as an outsider who didn't understand the complexities of naval architecture. Ships weren't dams. They required precision engineering, skilled craftsmen, and construction techniques refined over centuries. But Kaiser understood something the traditional shipbuilders didn't. In total war, speed matters more than tradition, and speed requires abandoning craft methods for industrial mass production. The challenge was audacious, even by Kaiser's standards. His Oregon Shipbuilding Corporation had built the Liberty ship SS Joseph N. Teal in 10 days the previous September, a record that stunned the industry. A reporter had asked Kaiser whether it could be done faster. Kaiser's response was characteristically bold: "We'll show you." What followed, over the next 4 days, 15 hours, and 29 minutes, would become one of World War II's most remarkable demonstrations of American industrial capacity, proof that traditional methods could be not just improved, but revolutionized through systematic application of mass production principles. Before understanding Kaiser's achievement, one must understand what a Liberty ship was and why America needed them desperately. The Liberty ship design originated from British desperation. By 1940, German U-boats were sinking Allied merchant vessels faster than British shipyards could replace them. Winston Churchill's famous assessment was stark: "The only thing that ever really frightened me during the war was the U-boat peril." If the Atlantic sea lanes were severed, Britain would starve and the war would be lost. Britain turned to America with an urgent request: build cargo ships, lots of them, quickly, cheaply. The U.S. Maritime Commission adapted a British tramp steamer design that was deliberately simple, using proven technology that could be mass-produced. The result was the EC2 SC1, designated Emergency Cargo, Second Design, Steam Engine C1 class, that would become known as Liberty ships. Specifications: length 441 feet 6 inches, beam 56 feet 10 inches, draft 27 feet 9 inches, displacement 10,500 tons, loaded 14,245 tons, speed 11 knots, 12.5 miles per hour, deliberately slow, cargo capacity 10,000 tons, range 17,000 nautical miles, crew 44 merchant mariners plus 21 Navy armed guard. Cargo examples: 2,840 jeeps, 440 light tanks, 230 million rounds of rifle ammunition, or equivalent mixed cargo. The ships were ugly, uncomfortable, and slow, but they were exactly what America needed: standardized designs that could be mass-produced using semi-skilled labor, with components fabricated across the country and assembled at shipyards. Traditional shipbuilding would take 230 to 355 days per vessel, using skilled craftsmen working piece by piece. At that rate, America couldn't replace ships faster than U-boats sank them. Kaiser would have to find a better way. Kaiser's innovations weren't individually revolutionary, but their systematic integration transformed shipbuilding from craft to industry. Innovation number 1. Welding replaces riveting. Traditional shipbuilding used riveting, heating metal rivets, driving them through holes in overlapping steel plates, and hammering them to create watertight joints. Riveting was skilled work, requiring years of apprenticeship. A good riveting crew could install perhaps 500 rivets daily. Kaiser's ships would be welded, steel plates fused together using electric arc welding. Welding was faster, 3 times as fast as riveting, required less skill, workers could be trained in weeks, produced stronger joins, welded seams were continuous rather than having rivet holes, and weighed less, no rivet overlaps. The established shipbuilding industry resisted welding, citing concerns about weld strength, brittle fracture in cold water, and quality control with semi-trained workers. These weren't unfounded worries. Early Liberty ships did suffer from brittle fracture, causing some to literally break in half in cold Atlantic seas. But Kaiser's engineers implemented rigorous welding standards, quality control, and material specifications that solved most problems. By 1942, Kaiser yards were welding 90% of joints compared to 10% riveting for critical structural connections. This single change reduced labor hours by approximately 30%. Innovation number 2. Prefabrication and modular assembly. Traditional shipbuilding assembled ships piece by piece on the ways, the sloped platform where ships are built. Workers would bring individual steel plates, cut them to size on site, fit them to adjacent plates, and rivet or weld them one at a time. It was slow, sequential work. Kaiser revolutionized this with prefabrication. The ship was broken into large sub-assemblies built in specialized shops away from the ways. Double bottom sections, the ship's floor complete with internal bracing, side sections, whole sides with framing already attached, deck sections, pre-assembled in 7 large sections instead of hundreds of small pieces, bulkheads, interior walls separating compartments, deck houses, superstructure buildings completely outfitted with bunks, fans, flooring, and fixtures before installation, engine room assembly complete with machinery, piping, and electrical systems. These massive sections, some weighing 60 to 80 tons, were fabricated in parallel at different locations across the shipyard. When ready, massive cranes would lift sections onto the ways and welders would join them. Instead of building a ship plate by plate over months, Kaiser assembled prefabricated modules in weeks. The scale of prefabrication was extraordinary. A Liberty ship contained approximately 250,000 parts. Traditional methods would handle each part individually. Kaiser reduced this to roughly 250 prefabricated sections that arrived at the ways nearly complete. Innovation number 3. Assembly line organization. Kaiser organized his shipyards like automotive assembly plants. Ships moved through sequential stations where specialized crews performed specific tasks. Station 1, keel laying and bottom assembly. Stations 2 and 3, side shell installation. Station 4 and 5, deck installation. Stations 6 and 7, superstructure and deckhouse installation. Stations 8 and 9, engine and machinery installation. Station 10, outfitting, piping, and electrical. Station 11, final systems testing. Launching ways, ship slides into water. Multiple ships progressed through stations simultaneously. When one ship moved to Station 2, the next ship's keel was laid at Station 1. Production flow never stopped. This assembly line thinking was heresy to traditional shipbuilders who viewed ships as custom projects. Kaiser viewed ships as mass-produced products. The difference transformed production times from months to weeks.
The record attempt for SS Robert E. Peary emerged from competition between Kaiser's own shipyards. In September 1942, Oregon Shipbuilding Corporation, Kaiser's Portland facility, built the Liberty ship SS Joseph N. Teal in 10 days. The achievement was stunning. Traditional yards took 230 days. Kaiser's Richmond yards averaged 50 days. 10 days seemed impossible. A reporter asked Kaiser if it could be done faster. Kaiser, never one to back down from a challenge, decided to demonstrate what his methods could achieve under optimal conditions. He designated the next Liberty ship at Richmond Shipyard No. 2, the 47th vessel from that yard, for a record attempt. The ship would be named SS Robert E. Peary, after the Arctic explorer who claimed first to reach the North Pole. The symbolism was deliberate. Just as Peary had achieved what seemed impossible, Kaiser would demonstrate shipbuilding speeds that defied conventional wisdom. But this wasn't just a publicity stunt, though Kaiser understood publicity's value. It was a demonstration of systematic efficiency. Everything that could be optimized would be optimized. Pre-work. Months before the record attempt, workers fabricated all 250 major sections. These weren't stored as random components, but organized in precise sequence for assembly. Each section was numbered, positioned near the ways, and ready for installation exactly when needed. Workforce optimization. Over 1,000 workers would work in 3 shifts around the clock. Crews were selected for speed and experience. Welding teams practiced coordination. Crane operators rehearsed lifts. Nothing was left to chance. Materials pre-positioning. Every piece of equipment, every spool of welding wire, every bolt and fitting was staged before the clock started. Workers wouldn't waste time searching for materials. Process refinement. Engineers analyzed every step, eliminating any unnecessary motion or delay. The goal was continuous workflow. As soon as one task completed, the next began immediately. Critics claimed this was a stunt ship, a one-time achievement possible only through extraordinary pre-work that wasn't sustainable. Kaiser called it an incentive ship, demonstrating what was possible to motivate workers across all yards. Both were correct. The Robert E. Peary was built under ideal conditions that couldn't be replicated for every ship, but the methods it demonstrated, prefabrication, welding, modular assembly, were sustainable and already in use across Kaiser's operations.
November 8, 1942, 12:01 a.m. The keel touches the blocks. Clock starts. Over the next 4 days, the carefully choreographed assembly proceeds with machine-like precision. Hours 0 to 24, Day 1. Bottom assembly. Workers weld double bottom sections, creating the ship's floor. By midnight, the entire bottom is complete, a task that traditionally took weeks. Hours 24 to 48, Day 2. Side shell installation. Massive curved steel sections, each weighing 60-plus tons, are lifted by cranes and welded to the bottom. The ship's basic hull shape emerges. Bulkheads are installed, dividing the interior into compartments. Hours 48 to 72, Day 3. Deck installation and superstructure. 7 massive deck sections are positioned and welded. The deck houses, already complete with bunks, fans, and fixtures, are lifted into position. The ship now looks like a ship rather than just a hull. Hours 72 to 96, Day 4. Engine installation and outfitting. The massive triple expansion steam engine is lowered into the engine room. Piping, electrical systems, ventilation, and auxiliary equipment are installed and tested. Hours 96 to 111. Final 15 hours. Final systems installation, testing, and preparation for the launch ceremony. November 12, 1942, 3:30 p.m. 4 days, 15 hours, 29 minutes after the keel was laid, SS Robert E. Peary slides down the ways into San Francisco Bay. The crowd, thousands of workers, military officials, and press, erupts in applause. Bands play. Cameras record the moment. The impossible has been achieved. But Kaiser wasn't done. Liberty ships required additional fitting out after launch, installing guns, loading supplies, final systems testing, and crew training. The challenge was complete delivery, not just launching. November 15, 1942, just 3 days after launch, 7 days, 14 hours, 32 minutes after the keel was laid, SS Robert E. Peary is delivered ready for service, a complete operational Liberty ship, fully equipped and crewed, built in 1 week.
The Robert E. Peary's record generated massive publicity. Newspapers worldwide reported the achievement. Nazi propaganda dismissed it as American exaggeration. German intelligence tried to verify whether it was real. Allied morale received a significant boost. America could build ships faster than U-boats could sink them. But the honest assessment required acknowledging limitations. This pace wasn't sustainable. The Peary was built using months of pre-work, optimal conditions, selected crews, and resources concentrated from across the yard. Kaiser's Richmond yards couldn't build every ship in 4 days. The average time remained around 50 days, still extraordinary compared to traditional 230-day construction, but nowhere near the record. Quality concerns emerged. Ships built too quickly sometimes had defects that appeared months later. The welding problems that caused some Liberty ships to crack were partly attributable to speed overwhelming quality control. Kaiser's yards improved welding standards significantly by 1943, but the early rush created issues. The design was deliberately simple. Liberty ships weren't sophisticated vessels. They were slow, uncomfortable, and had limited service lives. The EC2 design was chosen specifically because it could be mass-produced by semi-skilled workers. More complex warships couldn't be built this quickly regardless of Kaiser's methods. But even acknowledging these limitations, the achievement was extraordinary. Kaiser had demonstrated that shipbuilding could be industrialized. Traditional methods took 230 days and 1.4 million man-hours per ship. Kaiser's standard methods averaged 50 days. The Peary demonstrated that with optimization, even faster was possible. More importantly, Kaiser's methods were scalable. By 1944, his yards were completing Liberty ships in an average of 27 days. Not as fast as the Peary, but revolutionary compared to pre-war standards. The SS Robert E. Peary was ship number 47 from Richmond Shipyard No. 2. It would not be the last. Between 1941 and 1945, American shipyards built 2,751 Liberty ships, the largest class of cargo ships ever built. Kaiser's yards alone produced 1,490 ships, 27% of total maritime commission construction, built in 2/3 the time at 1/4 the cost of other yards. Kaiser's Richmond Shipyard specifically: Shipyard No. 1, 313 ships, Shipyard No. 2, 187 ships, including the Peary, Shipyard No. 3, 127 ships, and Shipyard No. 4, 120 ships. Total Richmond, 747 ships. These 747 vessels from 4 adjacent yards represented the greatest concentration of shipbuilding in history. At peak employment in 1944, Richmond yards employed nearly 100,000 workers, of whom 24,500 were women. The Liberty ship's impact was strategic. By 1943, American shipyards were building cargo vessels faster than German U-boats could sink them. The Battle of the Atlantic turned decisively in favor of the Allies. German submarine commanders who had terrorized Atlantic convoys in 1942 found themselves overwhelmed by increasing numbers of cargo ships that rendered sinking individual vessels strategically meaningless. Admiral Karl Donitz,
commander of Germany's submarine force, later admitted that once America's shipbuilding capacity reached full production, the U-boat campaign became unwinnable. You cannot starve an enemy that replaces sunk ships faster than you can sink them. The ship built in 4 days went to war and served honorably, if unremarkably, for the duration. Maiden voyage, November 22, 1942. 10 days after launch, Peary departed San Francisco, carrying cargo to Noumea, New Caledonia, and Guadalcanal. The Pacific Theater's island-hopping campaign depended entirely on cargo vessels supplying forward bases thousands of miles from America. Atlantic Service, April 1943. Peary transferred to Atlantic convoy routes, carrying war materials to Britain and ferrying prisoners of war from North Africa. D-Day, June 6, 1944. Peary was among the vessels supporting the Normandy invasion, delivering supplies to forces securing Omaha Beach. Total service. Peary completed multiple Atlantic crossings, survived U-boat attacks, and delivered thousands of tons of cargo to Allied forces in Europe and the Pacific. The ship was never torpedoed, never damaged seriously in combat, and never failed mechanically, a testament to Kaiser's quality control despite the rushed construction. The welding that skeptics claimed would fail under stress held up through storms, combat, and years of hard service. Post-war, December 1946. With the war over and cargo demand collapsed, Peary was deactivated and moved to the Wilmington Reserve Fleet, a California anchorage where hundreds of Liberty ships awaited scrapping or preservation. Final fate. June 1963. SS Robert E. Peary was towed to Baltimore, Maryland, and scrapped. The ship that set construction records became razor blades, automobiles, and structural steel recycled into peacetime products. No Liberty ship built in record time was preserved. The vessel that demonstrated American industrial capacity exists now only in photographs, records, and memory. Behind the record were humans. Over 1,000 workers who built the Peary in shifts, working around the clock under floodlights. Richmond's workforce was extraordinary in composition. Women comprised 24,500 of 100,000 workers at peak, 25% of the workforce, including 40% of all welders. African Americans comprised a significant portion, working in integrated crews, unusual for 1940s America and a testament to Kaiser's relatively progressive hiring. The women welders became known as Wendy the Welder rather than Rosie the Riveter because Kaiser yards used welding rather than riveting. These women, many former housewives, waitresses, or office workers, learned complex welding techniques in weeks and performed precision work that sailors' lives depended upon. One welder, Eastine Towner, a former waitress and African-American woman, reflected years later, "We knew those ships carried our husbands, our brothers, our sons. Every weld had to be perfect. Lives depended on our work." The pressure was immense. Work was dangerous. Heavy steel, molten metal, electrical welding equipment, massive cranes moving 60-ton sections overhead. Industrial accidents killed workers regularly. But the sense of purpose, building weapons to win the war, motivated crews to maintain focus despite exhaustion and danger. The Peary's construction required 3 full shifts working around the clock. Workers would complete 8-hour shifts, go home, sleep briefly, and return for another shift. The pace was unsustainable long-term, but for 4 days, crews maintained intensity that produced the impossible. Kaiser's achievement extended far beyond one record ship. He had demonstrated principles that transformed military procurement. Lesson 1. Standardization enables speed. Liberty ships used standardized designs with interchangeable parts. This allowed mass production impossible with custom-designed vessels. Modern military procurement still emphasizes standardization precisely because Kaiser proved its value. Lesson 2. Prefabrication multiplies efficiency. Breaking complex assemblies into modules built in parallel revolutionized construction timelines. Modern shipbuilding, military and civilian, uses extensive prefabrication pioneered at Kaiser yards. Lesson 3. Semi-skilled workers can build complex equipment. Traditional shipbuilding required years of apprenticeship. Kaiser proved that systematic training could prepare workers for complex tasks in weeks. This democratization of skilled labor had profound social implications extending beyond shipbuilding. Lesson 4. Industrial methods apply to military equipment. Kaiser's background in dams and highways, not shipbuilding, gave him fresh perspectives unencumbered by tradition. His assembly line thinking, borrowed from automotive manufacturing, worked for ships too. Modern defense contractors still study Kaiser's methods. Lesson 5. Speed matters in total war. In 1940, conventional wisdom held that quality took time and rushing compromised standards. Kaiser proved that speed and quality weren't mutually exclusive if processes were properly designed. In total war, the side that produces faster gains overwhelming advantages. Kaiser's achievement extended far beyond one record ship. He had demonstrated principles that transformed military procurement. Lesson 1. Standardization enables speed. Liberty ships used standardized designs with interchangeable parts. This allowed mass production impossible with custom-designed vessels. Modern military procurement still emphasizes standardization precisely because Kaiser proved its value. Lesson 2. Prefabrication multiplies efficiency. Breaking complex assemblies into modules built in parallel revolutionized construction timelines. Modern shipbuilding, military and civilian, uses extensive prefabrication pioneered at Kaiser yards. Lesson 3. Semi-skilled workers can build complex equipment. Traditional shipbuilding required years of apprenticeship. Kaiser proved that systematic training could prepare workers for complex tasks in weeks. This democratization of skilled labor had profound social implications extending beyond shipbuilding. Lesson 4. Industrial methods apply to military equipment. Kaiser's background in dams and highways, not shipbuilding, gave him fresh perspectives unencumbered by tradition. His assembly line thinking, borrowed from automotive manufacturing, worked for ships too. Modern defense contractors still study Kaiser's methods. Lesson 5. Speed matters in total war. In 1940, conventional wisdom held that quality took time and rushing compromised standards. Kaiser proved that speed and quality weren't mutually exclusive if processes were properly designed. In total war, the side that produces faster gains overwhelming advantages.
Henry J. Kaiser never built a ship before 1940. He was a dam builder, a highway contractor, a construction magnate, but not a shipbuilder. That inexperience proved to be his greatest advantage. He wasn't constrained by centuries of shipbuilding tradition. He didn't know that ships had to be built slowly by skilled craftsmen using time-honored methods. He saw ships as construction projects amenable to the same mass production techniques that built dams and highways. The traditional shipbuilding industry laughed at Kaiser initially. His yards used welding instead of proper riveting. He employed women and minorities instead of skilled white male craftsmen. He mass-produced ships on assembly lines instead of building them piece by piece as craft.
Everything about his methods violated conventional wisdom. Then he built 1,490 ships in less time and at lower cost than anyone thought possible. The laughter stopped. SS Robert E. Peary, built in 4 days, 15 hours, 29 minutes, stands as the ultimate demonstration of what systematic application of mass production principles could achieve. The record was never broken. It likely never will be, because modern ships are far more complex and shipyards no longer attempt such speed records. But the principles Kaiser demonstrated remain valid. Standardization, prefabrication, systematic process improvement, and workforce training can transform manufacturing timelines from impossible to routine. The dam builder who knew nothing about ships taught the shipbuilding industry how to build ships. That's Kaiser's lasting legacy, proving that sometimes the greatest innovations come from outsiders who don't know what can't be done. 4 days, 15 hours, 29 minutes. From keel to water. 250,000 parts, weighing 14 million pounds, assembled into a fully functional, ocean-going cargo vessel. The impossible accomplished through methods traditional experts insisted wouldn't work. Henry J. Kaiser, the man who had never built a ship, proved that sometimes not knowing the right way means you're free to find a better way. In memory of the 100,000 workers at Kaiser's Richmond shipyards, Wendy the Welder, and her colleagues who built 747 ships and proved that American industrial capacity, properly organized, could achieve production enemies considered impossible.